GIS is fundamental to our services to gas and electric utilities, in that utilities are run on information. To run a modern, effective, efficient, and safe utility, you need to have an understanding of your assets, where they're located, where your customers are, and how you're going to serve them. Obviously, GIS is fundamental to that, in that all of their assets and everything that the utility does is based in a location. Since everything happens somewhere, GIS is fundamental to understanding where that is and how those things interrelate with a wide variety of sort of external factors.
Being involved in GIS work is critical to our overall strategy here at ENTRUST because we want to work on projects that are significant and impactful to our customers.
Graph theory underpins the process we developed to help gas networks optimize R&B placement and distribution system segmentation. Modeling pipeline networks and their valves as a graph enables us to distill these very complex problems into their smallest possible representation. That allows us to algorithmically search for the optimal solution very rapidly, as opposed to the more manual process that we had in the past. We want to enable operators to efficiently plan the development of new safety infrastructure in their systems and ultimately be more safe and save them money. We have an operator, a licensee of the class location tool. One of the main requirements for the class location tool is continuously measured route segments in GIS that are uniquely named. This particular operator created routes in their GIS data based on pipeline diameter. In effect, what they were doing was creating, if you picture like a 2-inch and a 4-inch pipe coming together in the ground, what they were essentially doing is making two separate routes. So in the context of a class location, if we think about the sliding mile, many people would think, hey, we should bridge those two segments of pipe and make one route. So PHMSA, in interpreting the output of the tool, came back to that operator and said, you should really consider making a single route out of these two segments, since they do differ in diameter, but there's no actual physical impediment to gas flow from segment to segment. Changing your methodology is always going to have impact. In the context of class locations, we could perhaps see a lot of 1s go to 2s or class 2s go to class 3, so it is significant.
Working on a customer's GIS system gives us the opportunity to use our unique skills and experience to work on systems that are foundational to our customers.